Hey everybody, it's the Mayor Joe Helly, and today we're going to talk about a project that I've been working kind of hard on trying to develop and put together in the most sensible way for this video, and that is creating a basic C2 framework with SSH using the Paramiko library in Python 3. Most of this video is going to be a follow-along. We will stop along the way to explain some things in research from source, what we're looking at when necessary. However, this will be more of a demo, and I encourage you just to follow along line by line. So that you can put together the same product and project that I am. If you have not watched my previous two videos on DNS and subdomain enumeration, I encourage you to look at those videos in the description below and get an idea and a sense of how we'll be conducting training in my videos and see that they are pretty in-depth, that I don't know everything about Python, that I might call things the wrong name on occasionally, but in the end, I am good-hearted and just trying to put together some decent training. So. Much of this project itself is going to be pieced together from the Paramiko documentation. We're going to look at the Paramiko demo server to show you where I'm pulling some of the content from for this project. However, know that what we're doing essentially is we're hacking Paramiko itself in the client-server relationship. So when we think about client and server, and we'll think from the SSH perspective since that's what we're using, we have a server running somewhere and we want to access it through the SSH protocol. We do that through an SSH client. So if we know that the server is running and we have credentials for that server, we can access that server using the local SSH client and those credentials. The inverse in what we're going to do is we're going to essentially turn our server into our main way of communicating with our client itself. So instead of communicating from the client to the server, we're going to communicate from the server to the client and then from the client back to the server through some additional inputs and command handling. And we'll cover that and get to that when we get to that point, but I'll try my best to make sure that it makes sense to everybody. We will try to build out our server functionality first, and then we'll configure our client or implant to handle it. When we talk about C2 or command and control, what we're doing is on a very, very basic level. We're doing one client, one server at a time. A lot of times we might think of command and control as things like Metasploit, Cobalt Strike, Covenant, PowerShell Empire, etc. But even on the really, really low scale, something like a simple MSF Venom payload and Netcat could be considered command and control. You could set up a payload on a remote Windows machine to execute on startup or on action or event to communicate back to our listener. And again, that's a really, really low level command and control, but to me that's still command and control. You don't need big fancy team servers, you don't need expensive products. Really, we're just making sure that we can communicate with those remote machines to help us move laterally, whether that be user moving from user to user or moving from machine to machine. So again, we're going to build out our server first and then configure our client to communicate with it. And you're going to see me looking over here to my right most of the video. And that is because I will be taking from the script I've already written and we will develop it pretty much line by line. And again, when we need to, we'll stop and look at documentation. We're using Visual Studio Code, which I completely recommend that you use as well. However, it's not a requirement. You can use whatever you want. You could use Notepad, you could use Notepad++, you can use really anything, but for me, this has got the best functionality. So if you are following along with Visual Studio Code, first what I'm going to do is I'm just going to open up a new folder by clicking the Explorer button over here and clicking Open Folder. And you can see on my desktop I've already created an SSHC2 folder and it's empty. So I'm going to go ahead and click Add, and this will be our workspace for our project. And for some reason it's taking its time, but there we go. So now that we have SSHC2 as our workspace, I think we could probably rename that even if we wanted, but let's go ahead and click New File. And we're going to call this SSH Server.py and hit Enter. And it will open up a new Python document here in the center of our workspace for us to create our project. Make that a bit bigger so everyone can see it a bit better. And we've got to do our imports first, right? We need to import the libraries that we're going to use for our project. So as we talked about, we're going to import Paramiko. And Paramiko is a Python SSH library. It allows us to communicate over SSH protocols using this library. We're also going to need to import OS because we're going to need to interact with the operating system. Then we need to import socket because we will be working with sockets. We're going to be transporting our traffic from endpoint to endpoint across the network, and we're going to need sockets for that. So the first thing we need to do is set up a class. And I'm going to pull up my notes over here, and we're going to talk about classes real quick because I don't explain it as good as what some other things do. So let's pull up the Python 3 references here, and from Python docs, classes provide a means of bundling data and functionality together. Essentially what we're doing is we're creating a blueprint for our Paramiko server, for our SSH server here. So I encourage you to go through this documentation if you'd like to learn more about classes within Python. So we need to go ahead and we need to create this class, and in order to call a class or to create it, we just type class. We're going to call this SSH Server. And now what we need to do is we need to set up the Paramiko server interface. And as I said, we will be piecing together some of this project from Paramiko itself. So let me find our demo project. And this will be kind of difficult to see. But you can see here part of Paramiko's server is creating a class using paramiko.server interface. I don't believe you have to do this, but it will clean your project up quite a bit. And instead of having it all as one big function, you can split it up and you can call within that function this class. And that's what we're going to do for when we initiate our server itself. So let's go ahead. We need to put our colon at the end, and then we're going to highlight over here first. We can see server interface, and again, it defines an interface for controlling the behavior of Paramiko in server mode. Our SSH server here is simply our class, and then Paramiko here is our module. And we need to do it. We need to define a check channel request first, and this is something that we don't want all that stuff. We're going to use self, we're going to use kind, and we're going to use chan ID. And we're doing this because this is what, again, Paramiko will require us to do. And if we come over to the server implementation library documents for Paramiko, we can see some of the content that we need. So here we have the Paramiko server interface class. We need that to define the interface for controlling. We have the check channel request, which is what we've just initiated here with this function. And this will determine if a channel request of a given type will be granted and return open succeeded or an error code. So let's go ahead and work in that open succeeded or error code now. First, we need to say if kind equals session, and this is the default value for this. So again, if we come back to our implementation, you should see that kind right here. Our parameters, the kind of channel the client would like to open, usually session, so we're just going to roll with that. And then if this is true, if kind equals session, if that's a true statement, we're going to return paramiko.session, open succeeded. And again, this is coming from the Paramiko documentation. And then if it's not true, we're going to return paramiko.open failed administratively prohibited. What that means, again, it's over here in the documentation, so if we want to pull it up, we certainly can. But this is the default implementation for a fail condition. So if this is not true, this is the default fail condition. Next, we need to define something to authenticate to our SSH server, or what will manage the authentication mechanism. We could use public keys, we could use different encryption standards, but for our purposes and for simplicity of our client server, our implant server relationship, we're just going to use check auth password. We're going to use self here, username and password. And now what we can do after we've defined that, if we can use a if statement, so we'll do if username equals, and we can set whatever username we want here. This will be the username and password that we use for our implant to authenticate to our SSH server. In this case, I'm just going to use SSH user. And so both conditions need to be true. So both if conditions or if statements have to be true here. So and password equals SSH pass. What we'll do now is we're going to return Paramiko .auth successful. And again, these are default values within the Paramiko server documentation, so read into that if you would like. And if it is not true, so say SSH user is actually, if the implant is SSH user 1 for the credentials, we would return Paramiko.auth failed, which would return an authorization failed message to us, letting us know that we might need to modify our values, our default values within our payload to match our SSH server. Let's go ahead and save while we're here. And now we need to define our main function. And this is going to be the function that we use as what will handle our server. So let's go ahead and define main. And the first thing we need to do is we need to define our server. And in this case, we're going to use 0.0.0.0 so that we can listen on any interface on our attack machine. For port, I'm going to use 2222. And then let's go ahead and handle some of the things we're going to need for SSH. So when we think about SSH, we've got to have keys, right? Because it is a client-server relationship. We need to have keys for this to work. So first and foremost, we need to open up a terminal, and I just use the Control tilde button there. And if you're doing this on Linux, you can just use SSH keygen. If you're doing this on Windows, you're going to have to enable OpenSSH and go through that process. Find some resources online with Google to do that. And I promise if you like using Windows, it'll be rewarding in the end. I do most of my work on Windows now. So let's do SSH keygen. We need to generate a public-private RSA key pair. And here you can see my default file or directory here. I'm not going to change that to the directory we're currently in. So C drive users jwhel desktop SSH, and we'll see what directory this is. SSH2C or C2. And then we need to define the ID RSA name. We're not going to use passphrases here. And you'll see now that we have those files have popped up. We have our public and our private key for our SSH server. Again, take some time. If you're doing this on Linux, you can use SSH keygen just as I did. If you're going to use Windows, you have to have OpenSSH enabled. And I encourage you just to do a basic search on how to do that and enable that process on your Windows machine. Let's go ahead and clear this out, and we should be done here for now. And now what we need to do is we need to define where that key is going to be stored. So let's go ahead and set a variable called CWD for current working directory. And let's use a native OS library command called os.getCWD. And what this is doing is it's getting the current working directory on your operating system. And then let's set our host key value to paramiko.rsa key. And if we highlight over RSA key, we can see it's a representation of an RSA key that can be used to sign and verify SSH2 data. Again, up here as well, if we do get CWD, it tells you what that function is doing. So let's name our file name equals os.path.join. And what we're doing here is we're going to join this current working directory value with our file name, with our ID RSA value name. Key name that we have up here. So in parentheses now, let's do CWD, and that's calling from over here. If we highlight it, it's calling from our variable CWD. And now we can do as well ID RSA. And what that will do is when this program runs in its current working directory, it's looking for this ID RSA value or this key here. If it's not there, you're going to want to move it or generate it in that directory. Now that we've done that, we can try, because we want to set up a loop here. And now we need to set up the socket handling that's going to manage our traffic with our server. So let's go ahead and do socket, or sock equals socket.socket. And a lot of this is probably going to look familiar if you've ever done anything with port scanning or HTTP servers or anything else. You're going to see a lot of the same content or concepts here. So if we highlight over socket, this module provides socket operations and some related functions. On Unix, it supports IP and Unix domain sockets. On other systems, it only supports IP. For what we're doing, we're just worrying about that transport, so we're going to be working with the IP stuff. Let's do socket.af-inet, and again, these are standard values. If you want to dig into it more, you can certainly do some research into socket, and you'll see that here the AF-inet is just an address family. Then we're going to do socket.sockstream, and again, we can highlight over that, and we can see it's a socket kind. And then we need to use sock.setSockOpt. And if we highlight over this one, we'll see that we have some values here that we need to include. So let's go ahead and include socket.sol socket. And we will add socket.soReuse adder 1. And this 1 here is setting this to a true value or a true statement. And this would allow you to reuse this port multiple times on the machine. So if you wanted to run multiple SSH server.pys at once, you could. Once the connection is made. If you're just listening, obviously you wouldn't be able to do that yet because that port's going to be bound. But once the transport or the communication and the handshake has been made, then that port will become available. Sorry. Okay, and then we can do sock.bind. And what we're doing here is we're going to server import, and we're binding this service to our server, which in this case, we're setting this to all zeros, which will allow us to access on all our interfaces, and we're binding it to port 2222. Next, we need to do sock.listen, because we need something to handle the listener to accept traffic coming. And then finally, let's go ahead and talk about where we're at now. So let's add our value down here. So let's do if name equals main. And this is something that confuses me quite a bit. So we're going to pull this one up here in just a second. But what we're going to do is we're going to run our function. So let's pull up our notes over here, and I'm going to search real quick name equals main Python. And if we come down here to Free Code Camp, which is a great resource if you haven't used them, basically what happens when Python calls modules, and when the interpreter runs a module, the name variable will be set with main if that module that is being run is the main program. In this case, this is our main program, so we're going to use name equals main. I believe that's how it is. If it's not, don't shoot me, please. Again, I'm not a programmer. I'm just doing my best. So what we have here is we've defined our main function. We've defined our server port and current working directory variables. We have our host key set up so that when we go to run our program, it's going to call from this ID RSA key. And now what we're doing is we're setting a try state, a loop here, and we want to try some values, and then we need an accept statement, right? So let's do accept, and for now, just for simplicity, we're going to do keyboard interrupt, and we'll just quit. We also need something else here. So once we get the sock.listen, this will start the listener for our program. So when our client goes to attempt to connect to us, this is what is going to be waiting on the server for that connection. So what we can do is let's just put in a print state or a print here. We'll do listening for connections from Implant. Okay, so when this runs the listen, it will print out this value. And then finally, we need to set the values for the client accept, so or for the sock accept. So once the SSH server accepts that traffic, so let's do client and adder. We're doing this because both of these values have to be present. Sock.accept. Adder will actually not even be used. However, this this line of code has to have both of them. So just make sure that you include those. So what we've done here is we've listened, and then here our client address is going to accept it. And now we need to get down to some bread and butter. What we need to do now is initiate our SSH session. And we can set different variables for this, but for this, I'm just going to do SSH session. You can really use whatever value you want. You could call this SSH. If you have a neat name that you want to call a C2, you could call it banana C2, you could call it whatever. So you call this SSH value, anything that you'd like, but you have to be persistent throughout what we're doing. So we have SSH session, and then we need to do paramiko.transport, and we need to transport our client. So this value here, we're setting our client variable to the sock.accept, and what we're doing here now with transport is we're creating that new SSH session over an existing socket or socket-like object. This will create the transport object. It doesn't begin the SSH session yet. We need to use connect or start client, which we're going to do next after we initiate our key. Drink break. So our next task is to do SSH session .add. Sorry, we have to be case sensitive here. SSH session .add server key. And this is where we're going to call host key up here. So if we look at host key, if we double click, we can see that we're calling that host key now. Add server key. Adds a host key to the list of keys used for server mode. When behaving as a server, the host key is used to sign certain packets during the negotiation so that the clients can trust who we are. That's because we're using encrypted traffic, right? We want to make sure that that handshake is valid and that our client trusts it. So next thing we need to do is we need to set our server variable. And here we're going to call our class that we had up above. So if you remember earlier, we wrote out the SSH server class. Here is where we're going to initiate that server class within our main function. And now we need to start our server itself. So let's go ahead and do SSH session .start server. And we're going to say server equals server. And what this is doing is it's calling from this variable here, which uses the SSH server class from up above. If we highlight over start server, this is what's negotiating the new session on or as a server, which will allow us to have that connection. Next thing we need to do is we need to set a value for our session or accepting our session. So we're going to call this chan. We'll do chan equals SSH session .accept. If we highlight over accept, we see this just returns the next channel opened by the client over this transport and server mode. We could set a value here to really whatever we want, or we can just use no value, and then it'll just default. We need to set a we need to set a check next to see if the chan variable is going to be valid or not. So we'll do if chan is none. And we're getting this none because if we would print this out on a bad session, the value we would get back is none. So if chan is none, what we want to do is we'll just print transport error or session error or channel error, whatever you would like. And then we'll just quit because there's no sense continuing this. I'm going to put print chan here, and we'll come back to this, and I'll show you what a valid session looks like with this output. This is what I would call a debug print statement, and we'll just call this a debug chan output. And this will show in our terminal when we run this program and we get a successful connection from our client. So stand by on that one, but for now just put print chan there. And the next thing we're going to do is start working on the handler for when the implant connects to our server itself. So this will make a bit more sense once we get to the implant side, so bear with me. But basically what we're going to do is we're going to set up a success message that tells us that we've successfully received a connection from an implant. This is the check-in. So if you think of other C2s, whether it be PowerShell Empire, Covenant, Cobalt Strike, etc., you get some sort of check-in message that lets you know that the implant is here, that it's alive. This will be what we use for this. So this will print out in our server to let us know that this has happened. So let's do equals chan dot receive, and chan is going to be that channel between the two clients, between the server and the client, excuse me. We're just going to set up 1024 here. That's going to be our buffer. And then we'll do decode. This is because our traffic is going to be encoded, and we want to use decode to decode it as it comes back into our server. And then we can print. We'll use F here. If you remember in the other videos, when we use F, it allows us to call a variable. So let's go ahead and we'll just print success message. And this will make more sense once we get to it. We can make this success message whatever we want, and I'll show you how that looks later. And then finally, we need to, for functionality, include chan.send. And we're going to put just a space in here. This will allow some communication to happen that won't break our server-client connection. So trust me, just include this. It's going to be something you have to have. And I figured this out by not having it, basically. Finally, let's set up one function inside of our main function called ComHandler. And we'll talk about why this is necessary here in a few minutes. But basically, now we can set up the bread and butter of our server, right? This is what's going to handle that communication once the handshake is complete. So let's do try, and then while true. So anytime any of these conditions are true, continue, else we'll have some exception statements at the end. This is probably one of the neatest parts of what we're doing, and let's go ahead and call this command line. And this is where you're going to be able to start personalizing this for yourself, what the actual look of the output is. So let's do command line equals, and for me, I'm just going to put shell, pound, and then caret here, and then a space. You can put whatever you want here. You can put something fun, you can put banana, you can put strawberry, you can put whatever you want here. This is what's going to show up every time you run and you get a connection back. That shell there is just like your command prompt or your Kali prompt. So get creative, have some fun with this. Put whatever you would like in there. And then we're going to use command and set the variable to input. And what this will do is anytime input comes from command line, so we're going to call this first. So our command line will show in our server, and then it will have blank spaces after it. And anytime you want to run a command, this is where you'll do it from. The input part here is a Python 3 implementation. And what it does is it accepts raw input. It used to be raw input with Python 2, I believe. But what it does is it accepts whatever you've typed into the command line as the variable of this command. So let's go ahead and include our command line here because we want it to show up on, we want this value here to show up on every command that we run. And then we're just going to do a plus, and then we're just going to use 2 single quotes in a row with no space. And real quick now, we'll just come on down here, and let's do let's set a command real quick. Sorry, I'm trying to think of the best way. So I told you earlier in the video we would include a couple of commands that we can run. Let's do that. So let's first do an if statement. Let's do if command equals get users. So if our command that we enter into our command prompt or our command line input here is get users typed as that, what we will do is command equals, so we're setting our command variable to, let's do WMIC user account list brief. Now this is a Windows command. This will list all of the user accounts on the local machine. If you wanted to do something like get users for Linux, you could put cat etc password or whatever you want. But because I'm using Windows here, let's go ahead and do it like this. Now we're going to hack Paramiko a bit. So what we're doing is we're taking this input and then we're adding a whole bunch of if statements. If we were doing this the other way, our client would be communicating with Paramiko, and we would be entering those commands on the client. This is where we're going to start hacking Paramiko a bit. So we're going to use chan.send because we want to send through the channel that we have up here. Sorry. We want to do chan.send command. And what this will do is this will send our command to our client or our implant. And then we need to set a variable to accept it back, the return back. So let's do return value equals chan.receive. We'll just set a buffer of like 8192 because some of these are going to be larger. And now what we want to do is we want to print return value dot decode. If you remember up here, we had to decode this traffic. We're doing the same thing with everything that we receive because that's going to be encoded traffic. And next thing we're going to do is that's it, right? We've successfully accepted that traffic. Sorry, and we've sent it. So we've sent our command across the channel. This return value is what we receive, and then we print the received value. Let's go ahead and add in something that's going to handle something we often do. Just consider sometimes if we open up a command prompt and you hit enter, we want this to happen on our server as well. If you don't add what we're about to do, this will break your server and you're going to have to go back through the connection steps again. So let's save real quick and let's do if command. Wow, I'm really missing my keys there. If command equals, and then nothing. We're just going to do no command at all. We want to go com handler, and we're going to come back up here to this function. We're just going to recall the function, and that's it. Finally, let's put an else statement here. So if we didn't enter get users, and if we didn't enter nothing, we want something to handle all other commands that we might enter into our program or into our server. So let's do else try, and we're going to do chan.send command. And again, remember, this command variable is actually set up here with the input. So we're going to do chan send command. Our return value, like we did before, is just chan.receive 8192. We'll print that return value, .decode. And then finally, we need an exception here. You could trust me, or you can just go at it without using this try statement here. There will be a system error if the command is not valid, and it will break your program. So again, because we're mostly walking through this and we're not just going to get creative, this is more of a follow-along demo. I'm just going to include some of these except statements or these exceptions. You can get rid of these try statements and try it on your own and see what happens as well if some of this stuff doesn't work. But in this case, I know that we're going to need an accept system error. And again, this exception will pop if the command is not a valid command on the target machine. We're just going to go ahead and pass. And this is just going to keep our loop open, right? And then that's it for our commands for now. I've given you a bit of information on how you can add your own commands. Please get creative. Think about some ways that you can leverage different Windows commands, different Linux commands to be able to do this on your own. And really, it's just you take this and you copy it, and then you can just hit enter, and you can just paste it again and set up your syntax properly, and you can do this all day with different commands. Now that we have done our command handling, let's go ahead and handle this other try that we have here. So let's do just accept, exception as E, just kind of as a catch-all. We'll print the string value of E, and then we'll just pass. Let's add in an accept keyboard interrupt as well, which I don't think is really going to cooperate anyway, but we'll add it. We'll do a quit statement here. And then finally, we need to call this com handler function within our main function. So let's just go ahead and call com handler. And that is it for our SSH server. So let's go ahead and just take some time and go back through to make sure everything is in order. And then let's go ahead and run it. So for me, it's just F5 within Visual Studio Code. I'm going to click Python file. And with any luck, we should see that this runs, and and it's not working. Okay, so we have socket bind. Look at my script over here. And I believe this is because we need 2 parentheses. So I'm going to add in a second set of parentheses. We'll save this, and let's try running it again. Okay, perfect. And as you can see, we're listening for connections from our implant now. We don't have an implant yet. We got to program that next. So, but if we did, we would be able to connect. here in just a moment, we'll transfer over and we will start building our implant. Okay, so now that we have our server set up, we can start setting up our implant or our payload. And the way we're going to do that is first come back up here to our Explorer. We're going to create a new file. We'll call it implant.py. Hit enter, and now we have that new file. So some things that we have to do for our implant is, again, first we need to import necessary libraries. So we're going to do Paramiko. We're going to need some sub-processes here. What this will do is execute the commands for us on the target machine itself. So let's set this to sub-process. We need to import sys because we'll need that. We're going to import OS. Let's import Schlex. Schlex is a neat library which will allow us to do some work with analyzing the output and basically making it human readable and without getting a bunch of other junk into it like brackets and whatnot. So we'll go ahead and import Schlex. We're going to import socket because, again, we need to set up that client-server connection. Then finally, this will be optional, but it's something I'm going to include, and I'll show you why here after a while, is get pass. So now that we have defined or imported the libraries that we need, let's go ahead and define our main functions. So for us, let's do SSH-com. And we need to set variables that will help us with connecting. So some of those variables is IP equals, port equals, username equals, and password equals. So our IP address will be whatever the IP address is of that our server is sitting on. So in this case, I'm going to use 192.168.1.66. You have to encapsulate this in single quotes because the IP address has to be read as a string and not a integer. Our port, on the other hand, is opposite. It's going to be read as an integer and not a string. So if we come back to our SSH server and we look at our port value, we have 2222. So let's set that to 2222. We go back to SSH server, we confirm what our username and password is, and in this case SSH user and SSH pass. So we'll do SSH user and SSH pass. Now what we need to do is set up our client handler. And if we come back over to our Paramiko documentation, I'll type in Paramiko client, just like so. And this will cover the information that we have to have in order to connect to our server. So for our client-server communication. So we're going to need to set a variable equals SSH client. We're going to need to load system host keys, which in this case for us we're not actually going to do because we don't need to. We need to be able to connect to the client itself, and our commands, we're going to handle that later. So now that we dig back into our implant, then we've set our necessary variables for our connection. Now we need to set SSH equals paramiko.ssh client. And if we hover over SSH client, it just creates a new SSH client. Again, we saw this over here. If we hovered over the server interface, this creates our SSH server. The next thing we can do is we can do ssh.set missing host key policy. And we're just going to set this automatically. So let's do paramiko.auto add policy. And if we hover over missing host keys, this is the policy to use when connecting to servers without a known host key. So if we had our ID rsa.pub on our target machine or on our victim machine, this rule wouldn't be, or this part wouldn't need to exist. However, we're not going to ship our payload with an SSH key. That's just silly, right? So what this will do is this will manage this automatically for us. And then we need to set up our connect. So we have to be able to connect to our client. So if we do SSH connect, if we hover over connect, this will connect to an SSH server and authenticate to it, etc. So, and again, right here we see if the server's host name is not found in either set of host keys, the missing host key policy is used, which is what we have here. So let's set this, and we need some different values. We have to have our IP address. We have to have port equals port, and that's just calling from up here. Our username will equal username variable, and password will equal the password variable that we have. So all of these should link up here to these variables we have. And now we need to open our session. So let's do open, we'll just call this SSH session equals SSH, we're calling this variable here, .get transport .open session. If we hover over these, get transport returns the underlying transport object, and then open session requests a new channel to the server of type session. If we go back to our server, if kind session, this is what we're seeing. We're starting to see how these values and things start to come together, right? So over here, we're opening our session. It's sending that type, and then if the server receives type equals session, which it is, then it will return that open succeeded, or that connection will succeed, else it will not succeed. Let's go ahead and save. Now we're going to do a couple of other things, and this is kind of something extra that we're going to add in. It's not necessary. However, I think it's pretty cool to be able to send a message to our server letting us know what the host name is and the current user. So the way we're going to do that is we can just set h, a variable to h underscore name, or any variable you want. Just make sure that you're using it consistently. And we're going to do socket .get host name. And what this will do is this will get the host name of the machine that this implant is setting on. We can also do cur user equals get pass. This is why we're using the get pass library. Get pass.get user. And what this will do is this will return the current user for the environment. So if we're using this as my user JWHell on my local workstation or on my local Windows machine, this will return that that is the user itself. Now we need to set up an if statement for open SSH session active. So if this is an active session, and again this is just a true-false statement, the first thing we're going to do is we're going to send a message to our server. So let's do open SSH session.send. If we hover over send, we can see that send will send data to the channel, through the channel to our server. What we want to do here is we can do f, because, go inside the parentheses. We're going to use our f again so that we can call our variables here. Let's just call this implant checked in from hname as current or cur user, and then we'll just put a period and a new line. So this, once it connects, once our session is active, it will send this message. If we come back to our SSH server, we can see where this is received. Success message. This is where we were at when we were writing this line of code in. This is where the flow of our connection is at this point. So if the channel is accepted and opened, the implant sends this active send message. If it's active, it sends this message. This message is accepted right here. So that's how you get that. We'll go ahead and save. And then the next thing we can do is we can print open SSH session.receive 1024.decode. And then if we had a message back here, which we do, it's just this chan send and then this one space entry here. We have to have this again or it will break it. The client needs to receive something. So, and this is where we start to look at how we're hacking the client-server relationship with Paramiko. So we're just going to accept that single space data over to our client and print it. So now we need to do a while true. We need to set up, continue to set up our handling on the client side for handling the requests that it will receive. Let's do command. We'll set the command variable to open SSH session.receive 1024. So again, if we look at open SSH session, this is that session here that we have open. and then any traffic that it receives after this point will be funneled into this command variable. Now that this command variable is set, we can do try to set up a loop here. Then we're going to do SSH underscore command equals command dot decode. So what this will do is, excuse me, simply take that command and decode it locally so that the target machine can understand it, execute it, and then return it back. The next thing is, let's set in a basic exit statement or an exit handler for our implant. So if we're on our server and we say, you know what, we're done, we want to close this connection up, we can have a hard-coded command in our implant to do so. So let's do if SSH command equals exit. All this will do is assist.exit, and it will click, or it will close that connection. So again, it exits the interpreter by raising the system exit status. If the status is omitted or none, it defaults to 0, which is a success. If the status is an integer, it will be used as the system exit status. Doesn't really matter here right now, so we're just going to do that. So if the message we send over here on our implant is exit, this else statement is what handles that exit command, sends it to our implant, and then this if statement will handle that command itself. So if it receives exit as the command, it will kill the connection. It's all over. The next thing I'm going to do, which is really save you guys a lot of headache and show you something really, really cool that did cause me a lot of headache when I first tried to learn how to do this, is how to change directories. This is not an easy process. And there's a lot of competing information out there, and things might work one way on one script and then not work the same way on a different script. So pay attention here and then use this later on if you need to. We're going to say if SSH command dot split. What we're doing with split is we're going to split arguments on the command line. So it's going to return a list of the words in the string using a separate, or using sep as the delimiter string. So if you were to say cd c drive users public, if you were to cd to this directory, cd would be the 0 value. And if you've watched my other videos, you remember sys.argv values. CD would be our 0 value, and this would be our 1 value. We need to separate those from one another so that we can execute the actual command. So that's why we're using SSH command, or that's why we're using .split here. So let's do .split, and then we're going to do just double quotes with a space in between. And then if that first value in that command that's received by the client equals CD, what we're going to do is we're going to set our path first. So let's set our path to equals SSH command dot split, and we want the second value. So if the path will be equal to, again, if we do cd c drive users public, our path is equal to this here. This first one, or the 0, is our CD, and then our path itself is C drive users public. The next thing we need to do is we need to get the current path. So what we can do here is, or we need to change directory of that path, excuse me. So if we do os.chdr path, this will execute a Python command within the library or within the OS library to change directories to the value that we're setting in here. So in this case, path is calling up here to this path variable that we set, which is again the second value within our cd command. So we have cd and then we have our path. So we os.changedir, and then we want to get the current directory. So let's set curdir equals os.getcwd. And now we need to see how we can send our first command from the client back to our server. So what we can do is we can just do we need to set a variable, and for me I'll just do SSH command output equals, and we need to use subprocess to execute this command and then send it back to where it came from, right? With the results. So let's do SSH command output equals subprocess, dot check output. If we hover over check output, we don't get a whole lot of information here about what it is. But what it's going to do is it's going to run commands with arguments and return the output. We're taking that output and we're going to ship it back to our server. So if we were to use something like popen, this would execute inside the implant itself, and we would never see the value on our server. Using check output, we'll package it up all nice and pretty for us and then send it back where it came from. So inside of parentheses here, let's do schlex.split, and we want to take the value of SSH command, which again is right here, and what we want to do is include that, and then let's do a comma. I'm going to close our Explorer just for some extra room. And then we need to do standard, or stderr equals subprocess dot stdout. What this is going to do is this will set the standard error to standard out. So it's going to set our standard out message, no matter what it is, back to our target machine or back to our server. Let's just pull up really quick and look at standard stder and stdout. And we'll look at it in Python. So I'm over here searching for this right now. This is pretty important stuff, and it can be quite honestly pretty confusing if you haven't done anything before. So whenever we use print, for instance, it goes to sys.standardout. Whenever input is in, it's standard in, and whenever exceptions occur, it's written to sys.standard or std or standard error. We want to be able to get this standard error message, and we're going to treat it as the system out. So no matter what it is, it's going to come back as output to our target or to our server. Finally, we need to do shell equals true because we want to execute this as a shell command. I believe that's what that means. And now what we do is we do open SSH session.send, and again we're going to send it against our session we have open, and we're going to send SSH command output, this variable here. So this variable is equal to the output of this subprocess.checkoutput command, which is going to run our SSH command variable, which is taken from up here, and it's going to send it back to our server. Our server is receiving this traffic, and we'll see if we can find the right place. Yeah, it's going to be in here. So anytime we receive that traffic, it's going to ship it back right here, so as the return value. So, and for us, just any generic command will come here as return value, chan receive 8192. So anytime we execute a command such as this session will send it. It's going to come back to our server. Our server will process where it belongs. In this case, the if command was not get users, so it's not going to come here. In this case, the if command was not nothing, so it's not going to come here. So it's going to fall back on our else statement, which will be here. So we'll take that return value, which is that chan.receive, from this open SSH session.send. It will process it, decode it, and print it. So CDing, that's all we did right there was change directories. You can see it's kind of complex. It can be a pain in the butt. Take this, make some notes about it, and you'll see how you can tinker with it a bit. But really, it's a great thing to have, and I encourage you to use it as much as you can for yourselves. All right, so finally, we can do an else statement. So as we saw with our server and the else statement over here, it's kind of like a catch-all. That's what we're going to do over here as well. We're just going to catch all. So if we don't have exit as a value, as the variable SSH command, and we don't have CD as the first value in the command, we're going to do something else. And that something else is going to set SSH command, sorry, stumbling over my words, SSH command output equals and we will do subprocess dot check output as we did before. And now what we're going to do is we're going to take SSH command as our variable instead of something like what we had here. So let's go ahead now and just look at my code quick. Open SSH session We didn't want this. Okay, so we have to look at this again. Sorry. Let's come back to our CD. We don't want it to be OpenSSH session send this. We want it to be OpenSSH session send curter. So let's do our F, and then we'll just do curter. You can put some different stuff in here. You can say curter equals or whatever. You could just put curter alone in here, but let's just do it like this so that you can customize it. Sorry for the backtrack there. This SSH command output, I'm just looking at my script real quick. That should be okay, right? Yeah, that should be okay. If not, it'll tell us when we run it. Okay, so finally our else statement, SSH command output equals subprocess check output. And if we do it inside of our parentheses, we'll do schlex again, dot split. And then inside a second set of parentheses, we're going to do SSH command. It's going to pull that variable from up here. And then we're going to put in the same values that we did before. So we'll do standard equals subprocess dot standard out. Then we'll do shell equals true. I don't think we need two of these. Yes, we do need two. Okay, we have to add a parentheses there, and then perfect. Okay, so we have our command output. Now we can do OpenSSH session.send. Again, we're going to send that traffic back from the standard output, from the command that we get here. And let's do .send SSH command output. And perfect. So I'm going to... Yeah, no worries. Perfect. Okay. So that should work correctly if I'm not mistaken. All right. So anything else that's not exit or CD will process here. So it will take the SSH command and execute it. Make sure I've got this right. Okie doke. All right. So that should work. And this one's a bit more complicated than the other one, so forgive me, please, for looking back and forth and processing stuff in my head. Now we need to handle our exceptions, so we'll just do accept exception as E, and let's do open SSH session.send. We're just going to send blank traffic back. So if you were to send a bad command or something that doesn't work, we're just going to return back an empty value. So if you hit enter, as we added in over here in this case, but if we were to type in like help H or an incorrect command, this is what's going to handle that incorrect command. Instead of breaking the program and saying no more, this isn't going to work, this is all it's going to do. It's just going to send back that message. Let's do accept keyboard interrupt, which again, this may or may not work for you. I wouldn't take it as the end of the world if it doesn't. Let's do accept command equals session interrupted. And then we'll do open SSH.send accept command. And then let's just do quit. Then finally we can add in a return over here to handle it. Okay. Now again, if you remember in our SSH server portion, we had the if main, etc. over here. I'm just going to copy this and we're going to paste it. We're just going to confirm that we do not have main as the correct variable. We have SSH com. So let's just go ahead and change this to SSH com. And we can save now. So let's make sure that the IP address is correct, our port is correct, and our username and password are correct when compared to our server. And we see that username and password's right and our server and port is correct. So now what we can do is let's start up. I'm going to open up a PowerShell terminal over here. And I'll cd to desktop and then SSH C2. Let's do Python 3 SSH server.py. And you can see that we're listening for connections from our implant. I'm going to open up a command terminal next. And just we'll cd over to the same place. So cd desktop SSH, and here we'll do Python 3 implant. And you should, if everything worked correctly, see now that we have implant checked in from the Mayor laptop as JWHell. If you go back to our SSH server where I told you we would print the value of Chan, this is what that traffic or that variable looks like. It will give you a little bit of information about the cipher it's using. It's got one active open channel, etc. This is just a simple debug. You can go ahead and delete that portion of the code if you would like. I use these on occasion when I program things myself because it does give me a good idea of what's going on the back end, and I've really learned a lot from what some of these messages refer to or look like when they execute. So let's just quickly, we'll do who am I. Let's test those commands that we wrote into our server. So I'm going to look at get users. So we have get users here. You can see that it's here. It might print out twice for you sometimes. I can't get it to stop doing that. I don't know what it is. I apologize. If you all can figure it out, please share in the comments so I can stop pulling my hair out. Let's see current dir. So let's do dir, and we can see we're in SSH-C2. Let's cd backwards. You can see now that it returns the current directory that we're in now. That is because if we come over here to cd, we can see that it's this this curdir here. So that's exactly why that happened. I think we can close this out. I'm going to try this and see if it breaks things. Let's type exit or quit, and we can see that our socket is closed. I'm going to run this again and see if maybe this is what's happening. Alright, so let's do get users again. Nope, that's not why. Okay, no worries. If anybody can figure out why that's printing twice, please share in the comments. It would save me a whole world of grief. Let's cd backwards. We can see now that we have, we're able to cd back and forth, etc. Again, this is the basic framework for our SSH C2 or our Paramiko SSH C2. Again, your general concept of SSH client-server relationship would be you would be working from the client to access the server. We are working from the server, as you can see here, to access the client, execute commands, and then send it back. So I really hope y'all learned something with this one. This was a lot of fun, and it took me about a week of tinkering to figure out the perfect path to take this project down for y'all. So please leave some likes. I would love to see comments and to hear about how your project went as well. I am trying to grow my channel, so if you want to share it on Twitter and LinkedIn with your friends, I would really appreciate it. Look forward to some more videos here in the future, and thank you so much for joining me. And if you like these videos, again, please leave a like and subscribe. It would really be appreciated. Until then, see you next time, guys. Take care.